Hello, everyone. Welcome and thank you for joining us for this year's State of Analytics Engineering Report webinar. We're here today to discuss with you the latest, the greatest trends in analytics engineering. And so today we are talking through the 2024 State of Analytics Engineering report. This report was comprised of 456 data practitioners, data leaders from across the industry, and we asked them about how they were using analytics engineering and DBT to create their data workflows. And this is the second time we've run this, and it's just like always so great to get a grounded sense of what people in the industry are actually working on, what their top priorities are, what their challenges are, and how they're thinking about the future. And I'm thrilled to be here today with Ian Macomber and Lauren Benezra, two of my favorite people in the industry, to talk through some of the learnings and reports for this. So let me give you a quick intro to, first of all, myself. I am Jason Gans, manager of the developer experience team here at DBT Labs. And I've been a long-time analytics engineer. I started using DBT in about 2017, and it really transformed my career, the way I think about data. And it's been so cool to get to see the rise of the industry and get to interact with data practitioners from across the globe. Data practitioners like Lauren Benezra, Senior Analytics Engineer at DBT Labs, who has been working with data teams across the country, helping them implement DBT and organize their data workflows. Lauren, how did you get started in analytics engineering?
I spent a lot of my time after grad school at a really small startup, and I was basically handed anything that had code. And so I did all of their laboratory automation. I wrote a whole bunch of really weird apps that printed random tiny labels on little tiny bottles. And then we built a warehouse. And so I was handed the warehouse and handed DBT and had to figure out what in the world was going on.
That's such a great story. It's such a classic intro of being like, okay, we have this awesome thing that is a data warehouse and analytics engineering. What do we do with that? And someone that knows the answer to that is Ian Macomber, who has been on at least two legendary data teams to my account. The first at Drizzly, who were early adopters of DBT, and now the data team at Ramp, where they're just doing some of the coolest stuff in the industry. So Ian, do you want to talk about your intro to analytics engineering and kind of how you think about data teams?
Yeah, absolutely. So I've been in the data space for about 11 years now. And that actually means that I did get the extreme tail end of on-prem SQL servers. So I started my career at Wayfair in Boston. Every once in a while, we drive out to Waltham, unplug some servers, plug them back in, which is great mostly because, my teammates who are 2 years younger than me have never known anything other than cloud. So I get to sort of lord that over them, that I was there for sort of truly one full generation of tech stack ago. And during my time at Wayfair, I learned a lot about how, a big international, soon-to-be public company thinks about building single sources of truth. And I think what was sort of exciting about that time, right, is you could do work that would influence, the company leadership. But that was also kind of where it stopped. I think really for me, back in the day, the biggest mistake or most wrong you could be was putting a number into a slide deck for a board meeting that didn't make sense. When I think about, the next stages of my careers, both at Drizzly and Ramp, so much of the incredible infrastructure around the modern data stack has allowed data professionals to really expand their scope, right? So we're not just powering single source of truth 24-hour batch reporting dashboards. We are sending emails. We are moving data into Salesforce. We are adding context to customer service tickets. We're building actual data products For Ramp, the data team is really responsible for whether or not a credit card transaction goes through, which is certainly like a both higher leverage, lower latency, and sort of can go more wrong faster than a number being off in a board deck. And so very generally, I think like that's sort of been my background, and what I'm excited about these days is kind of continuing that surface area of how can data power more things at a business.
Yeah, that's the increasing move into operational use cases is something that has been really, really cool to see the team at Ramp getting into. And I think that's one that we will be hearing about in future years version of this this same webinar. So I want to thank everyone in the audience for joining here today and give you a brief rundown of what we will be talking about. So first, we want to take a look at the long arc of analytics engineering. That's actually really important for this year's State of Analytics Engineering report in particular, because we're kind of at an inflection point in the industry. And when that happens, I think it's actually really helpful to kind of go back to the beginning and think through how we got to where we are today, and then what that means moving forward. And after we do that, then we'll take a look at some of the top themes from this year's report, take a look at how specifically data practitioners and data leaders can use the insights from this report, and then we'll move into Q&A. And the goal of this presentation is really to have a conversation with all of you in the audience. The report's there, it's online. I highly recommend that you all read it. And we're going to want to hear from you beyond just what's directly in the report, but really what your questions are about the overall analytics engineering industry right now and how you're thinking about it and some of the ways that that might shape our workflows moving forward. So with all that, let's get into it. And I want to start us with a flashback to the publishing of the DBT Viewpoint. So the DBT Viewpoint was written in the very early days of analytics engineering in around 2015 or 2016. And the Viewpoint raised a set of philosophies about how analytics work should be done. That analytics work is collaborative and it should be treated like code. You should write your analytics projects using version control. You should test them. You should make it modular. You should use the insights from software engineering and bring software engineering best practices into your analytics code. And it's funny looking at this now to remember just how unusual this viewpoint was at the time. This was not the way that data teams were operating. Data teams were often doing a lot of manual work to pull one-off reports. Things were happening across different systems. There's very little standardization. And we were just at the beginning of cloud data warehouses, starting to make it so that Ian didn't have to drive out to Waltham and unplug a server to turn it back on. So the DBT Viewpoint really served as a kind of grounding and foundational document for DBT and analytics engineering. And that drove the early adoption of DBT and the first wave of companies starting to integrate these into their work. And what we saw at this year's Coalesce was this is now a real thing for companies across the industry where all of the ideas in the DBT Viewpoint, they're not revolutionary anymore. They're kind of the table stakes of doing business and doing data work today, which means that a lot of the early challenges have actually kind of shifted. And so whereas a decade ago, data transformation was one of the biggest challenges data teams faced, today, transformation is actually not one of the top challenges that we found in this year's report. So this was I think the prime takeaway from this. I want to share a quote from Madi Caribbean, who shared this on LinkedIn. He's a staff analytics data engineer at Zendesk, which is that today the two biggest challenges that data teams face are poor data quality and ambiguous data ownership. And these are mostly related to people and processes rather than technical complexity or the data platform itself. This is the big shift from the struggles of the pre-modern data stack world. As someone who started working on data platforms during the Hadoop era, it's inspiring to see the industry move past spending endless engineering resources on maintaining complex data infrastructure that had terrible return on investment. In a way, this is an acknowledgement of the modern data stack's role in solving one of the Hadoop era's biggest challenges. And today's data platforms mostly just work. The modern data stack may be dead, but for all its flaws, it has solved the data platform's technical hurdles. Now it's time to solve the business ones. And I think that that's such a great grounding quote to begin today's discussion with, because it really, it acknowledges two things. One, we've come a long way as an industry, but two, there's still a lot of work left to do. So with that, I want to get to today's first theme, which is that mature workflows require mature reliability and organizational structure. So Ian, when we were talking last week, you said something really interesting, which is that the best data teams have their analytic systems relatively figured out over the past few years. Not that everything is known, but that we have a pretty solid understanding of how to architect these systems. And so can you tell us a bit about the technical and organizational systems you have in place to ensure that your analytics processes keep running?
Yeah, absolutely. And I don't think it's going to be anything all that unexpected. I would say from my perspective, the modern data stack of how to orchestrate on a 24-hour cadence has been really well dialed in for a couple of years. We can hire analytics engineers who are familiar with how to organize DBT projects. We bring best practices to software engineering, or from software engineering to data. I think a lot of the challenges now for us largely revolve around sort of this sort of truism that I've learned, which is if you do something that people say, yes, this is valuable, and it appears in a BI tool every 24 hours, they really ask for three things, which is they say, I want to put this somewhere else, I want to operationalize it, and I want it faster. One of, I think, actually the incredible, I guess I didn't even know sort of how lucky I was until I've moved to a different world, right? Is that if you have a BI tool and it's running on a data warehouse, the data team is responsible and owns almost 100% of what goes into that BI tool. So if something's off, I think it's actually, in a weird way, nice, because there's only one person who can say, hey, the numbers look wrong to. And then the data team knows that they have control over it. As you think about the rise of, reverse ETL, we might write to Salesforce. Another team might write to that exact same column and row in Salesforce. There might be something that's event-driven. There might be a human being who's updating something manually. There might be a batch update. There might be some API connector with Zapier or Workato or something like that, followed by, sort of the classic reverse ETL sync. As we integrate with more tools and systems, the data team, I think, increasingly does not have that 100% ownership over our surface areas. And so that, to me, is, I think, kind of like one of the surface areas that I think I'm most interested about in terms of how can software engineering techniques apply not just to a data team's ability to provide single source of truth, accurate data on a 24-hour batch basis, but how can we also bring software engineering best practices as we insert data into more places and more operational decisions.
Yeah, that's a really interesting point. And it goes to show with the top challenge being ambiguous data ownership, that people are saying that, okay, we haven't solved the problem of data transformation. There's still, and the interesting thing is, if you look at how teams are spending their time, maintaining data sets is still how data teams are spending most of their time. But like, we more or less know how to do this. But then as we're bringing in other systems, as we are bringing this data kind of like close to the metal of our organizational processes, which is great, and then it's like, okay, how are we How are we making sure that these teams are kind of correctly owning their data, that you have contracts to ensure that the data that's coming in is reliable, and that you know who is in charge of which data sets. All right, next question is for Lauren. And Lauren, we're mostly going to be talking about large and enterprise scale data today, but it's also true that the analytics engineering workflow has really shifted what's possible for organizations of all sizes. And I know that you've done some really great work here. So can you tell us how analytics engineering is affecting more scrappy organizations?
Yeah, absolutely. By scrappy, you might mean a cat stack. For those of you who have not seen the Coalesce Scrappy Cat Stack talk that I did last year, I ended up building a very cheap, very put together piece of modern data stack for a cat rescue that I volunteer for. And really the point of it was to show that, when you are kind of in that in-between stage of outgrowing Google Sheets, outgrowing Excel, you need to get rid of these silos and these repeated pieces of data. You've outgrown these little pieces. What you can do is you can actually start building a data stack, a real data stack with a real warehouse with pretty little overhead. You can do a dbt Cloud developer license, right? And get a free dbt Cloud project. And then you already have an orchestrator. Awesome. If you've got Google Sheets or you've got something like, Airtable, something like that, like you can start to connect these things really easily. There are so many different pieces of the stack that you can get for very, very little money. And so you can kind of start to build this out without a ton of overhead, a ton of expertise. Like you can really just put together the pieces. And I think starting small is huge, right? I mean, it's really, really hard. I've worked in another company that was really small and had a lot of very siloed data in Excel sheets on individual computers, as many startups start with. And it's hard to get from there into a data stack. So if you can get things into a warehouse quickly, you can at least organize that data and start to do more with it.
Yeah, so I think like the theme between each of your answers is that what we've unlocked now is the modern tooling that we have for smaller organizations enables the scale of analytics powered workflows that previously were a struggle even for the largest and most complex organizations. And so that's kind of baseline and table stakes. And now that we have that, we can start to look ahead to, okay, what does having this unlock for us, and how can we take this accurate data, work it into our workflows, and go even further with it? So small organizations benefit from this, and large organizations are able to really kind of redefine what it means to do and to work with data. Okay, so we've been talking a lot about kind of the rosy side of the picture, but this year's State of Analytics Engineering report was not all about rosy. One theme that came up particularly was the macro environment and that putting pressure on data teams. I think we all felt this in the industry over the last year with waves of unfortunate layoffs in some data teams and downward pressure on budgets for tooling. I think that we saw 41% of teams see downward changes in budget due to the macro environment, but I'm willing to bet it's around 100% that felt this in some way or other. So, Ian, I'm curious to hear how you were thinking about the shift in the macro environment, and like what you saw yourself and what you were hearing from your peers on other data teams as the macro environment was building this pressure.
Yeah, absolutely. And I can also speak to this a little bit just based on what RAMP does and the data that we have. So RAMP is a finance platform. We have corporate cards, we have bill pay solutions. And what it largely means is that we have a frontline view into how companies spend money and how that changes over time. And just sort of like one relevant anecdote here. In March of 2021, we saw that about 30% of all credit card spend on Ramp was on ad networks. So this is Google ads, Facebook ads, stuff like that. By April, actually, this might have been 2022. April 2022, that I believe is when the Fed raised rates. And we saw that number plummet from 30% to 15%, basically in a month, which is pretty crazy, right? You're like, all of these businesses have cut their ad spend so fast. And I can tell you sort of exactly what happened, right? Which is that investors are saying, hey, you need to tighten your belt a little bit. You need to make this money last longer. You need to tighten your CAC to LTV goals. And then if you think about what parts of a business are fixed versus not fixed, ad spend is actually the very first big lever you have, where no one at Facebook is going to sort of like yell at you if you cut your Facebook spend pretty substantially. But I think that same analogy sort of holds all the way down, which is like, what parts come next? Hopefully layoffs are last. I think we actually even see that spend on, core cloud, like your AWS bill, probably comes even after layoffs in terms of like what things that are hard. But for me, I would say you have to think a little bit more about profitability and less about growth as an entire company. And then mapping that back, what does a data team need to think about as a result? I think initiatives to cut cloud spend are more important. I think initiatives to think about where you can bundle things, right? So much of the modern data stack is around, there are all of these incredible point solutions that let you be very effective, but it costs a lot to have all of these best in stack tools. Where there are situations where a platform might be a little bit better. And then additionally, from a procurement perspective, where are you getting good deals? I think spending more time on that stuff ends up being important. If you think about some of the tools in the data stack space, they have some of the famously highest net revenue retention numbers of all SaaS companies. I think most people on this call probably know that if you pay Snowflake $100,000 this year, you're going to pay them $140,000 next year. That's like why Snowflake is such an incredible company, why it's such an incredible stock. But I think being able to anticipate this, thinking about where you can consolidate, thinking about where you can be a little bit more proactive about, hey, let's not bring in all the data just in case. Let's use data, let's use compute, let's use tools just when we can prove they have like a very bottom line impacting use case. I think these are sort of the things that we've been trying to do, and a lot of the things that we've seen the businesses on Ramp be trying to do as well.
Well, that credit card spend statistic is wild. It's so cool that you all had a front row seat to kind of see that in real time. But yeah, I think your point about making sure that kind of we're able to tie the data work that we do to kind of operational business wins and get that connected to the initiatives that the rest of the business are looking into is it's always been top of mind, but it's more top of mind than ever. Lauren, you had some interesting thoughts about how this is affecting kind of like the day-to-day work that's getting done on data teams. Can you talk about that and how data teams and leaders should be thinking about this?
Yeah. For the past 3 years, I've worked on our professional services team. So I've essentially worked with all kinds of different companies that needed help on a project or needed some advice on their DBT project or their stack or anything like that. And what I've seen is that there's a whole bunch of data teams that, of course, are now much smaller, right? I mean, we've seen companies across all tech industry, that the entire tech industry that have essentially just done RIFs. They've gone through these big reductions. And so we see a lot of, like you're saying, pressure on these data teams to do the same job with fewer hours, fewer people, right? And it's tricky. I mean, I think you have to really start to prioritize what needs to get done. The same amount of work just will not get done as it did before. And I think one of the big things that you can actually do is ensure that your systems are running smoothly. I mean, I've seen a lot of teams that have, and I've been on teams like this before, that have these kind of fragile, very custom built pipelines, really custom scripts, and they need full-time people to be looked after and maintained. And when you have that stuff, I mean, and you get rid of that one person, you're essentially letting that break. and then expecting the smaller team to do that same maintaining. So I think tools are really important, especially when there's more pressure on data teams right now. You have to have really working, really reliable tools in order to get everything done.
Yeah, that makes sense. You want to make sure that you have kind of a set standard process in place and that you kind of know what your workflows are and how it's getting done. All right. I want to make a note of something, which is we're doing a webinar in the year 2024, and we made it 25 whole minutes before the words generative AI were said. And honestly, I think that might be a new industry record. But don't worry, folks. If you came to here to talk about generative AI, we are, of course, going to talk about it. What to talk on here? Honestly, we could probably do a full hour just on this, but we will keep it relatively quick on this. But Ian, you guys are doing some really, really cool stuff with AI, particularly around kind of using AI to get at data that was not previously accessible in your analytic systems before. Can you talk about how you're integrating generative AI into your workflows?
Yeah, absolutely. I think first thing I'd say, right, is like same thing as everyone else. The answer I would have given you 3 months ago is totally different. The answer I'm going to give you 3 months from now is totally different. But I can talk both about sort of what we're seeing in Ramp businesses as well as how Ramp is integrating on our own. I think the first is a phrase I love for build versus buy is build what is necessary and strategic, buy what is necessary but not strategic. That's loosely how we're thinking about it at Ramp. And just as an example, we use Zendesk. I'm positive Zendesk is going to get better at using NLP and generative AI to answer customer service tickets. We want to be there for it. We want to consume it. So I want to talk a little bit more about the stuff that I think is specific to Ramp. And for us, there's really 3 types of documents that we think we need to be world-class at pulling out context and understanding. And for us, these are receipts, they're invoices, and they're bank statements. And so I'll talk a little bit about invoices to begin with. We have a bill pay product. Because we have that bill pay product, we are able to see thousands of contracts and invoices that people upload. The way we started building our price intelligence project was to bring 4 people into a conference room, print out a whole bunch of Salesforce contracts, and we actually just circled them. We were like, okay, what are the points here? Like, what are the relevant things? And we actually ended up handcrafting JSON blobs out of those contracts. This is an expensive process, right? Like having 4 people in a room go ahead and do that. From what we've seen, the generative models are not yet strong enough to say, here's a contract, tell me what's valuable. But if you prompt them very precisely because you know what is valuable, they're actually quite good at that. So once we had a concept of what a Salesforce JSON blob could look like, we put that in our prompts, and for somewhere between 2 and 10 cents per contract, which is obviously like rapidly falling, every single time we get a Salesforce contract, we turn that into a JSON blob. We upload that JSON blob into our data warehouse, and we run the absolute simplest summary statistics that have existed forever on top of that, which are averages and means and medians and 90th percentiles. This lets us see a couple of things, and I'll actually tell kind of like one anecdote that might have been us outsmarting ourselves. We did this for Slack and Figma. We just saw a flat line. We went to Slack and Figma's website. They don't have enterprise pricing. Everyone just says, like, they tell you on their website what their price is. And we kind of like backed into it by looking at the data points. But that's actually exceptionally valuable because we can tell you, just don't negotiate with Slack and Figma. Everyone sells the same price. And we can tell you where you can negotiate. And so for, to kind of talk a little bit about it, right? Like I think in a consumer application, what feels magical about a chat GPT is you can put in 3 bullet points and it can expand to an email. We really like the other direction, which is going from more context to the most important things. So generative AI for us, where we've seen the most value, is taking these large unstructured images and PDFs, being opinionated about what the structure looks like, converting it to semi-structured data, then uploading it into a world where you can just run SQL on top of it. So super generally, that's kind of how we've used it so far.
I really love the way that you frame that of taking unstructured data and then being able to use generative AI to turn that into structured data and then do more or less kind of the traditional analytics work that you would be doing on top of it, but with access to kind of a whole new set of business impacts that just like wouldn't have been financially feasible or like practical via time or able to map into structured data beforehand. It's a use case that we're seeing in a couple of different places. We actually do this internally to take our community product feedback from the community Slack and make sure that if something is mentioned that we might not have seen, we just post a little summary to make sure that people are getting it there. And that's it's been really great to just be able to do normal analytics engineering, writing DBT models, scheduling it, setting up your reverse ETL, but then you have a whole new domain of things that you can do it with. So that's one application here, which is bringing structured data workflows to data that was previously unstructured. One of the other things, of course, that we hear about with analytics engineering and AI is helping you actually build your projects, write your code, test your code, things of that nature. Lauren, I'm curious to hear kind of how you have been thinking about that.
Yeah, I mean, from what I've seen across teams, I work with a ton of individual contributors. I work with a ton of developers across the entire world, honestly. And all of the ICs are spending a lot less time thinking about AI, I think, than leaders are. I think they're spending more time actually trying to get their work done because there's still so much work to get done. And AI doesn't necessarily make it faster all the time. And trying to break that down and figure out what is going on and how we can best use it takes time. It takes time out of the workday. So I think what I've mostly seen is code gen is basically like, what's that one piece of Jinja? How do I write that one, that window function that I can never remember the syntax for? That kind of stuff is really, really helpful to have those kind of like chat bots in your tool because I don't want to have to leave DBT to go like look up something that I've forgotten. And Jinja is, if you all are DBT people, Jinja is not necessarily the most friendly language. Like there's funky things that happen, you can't necessarily do like iteration on top of a number. Like there's weird things that exist in Jinja. So sometimes trying to get into that, understanding the syntax and getting the right syntax is really helpful with just a nice little chatbot.
Personally, I'm looking forward to never having to write another regex in my entire life.
Yeah,
that was the first domino to fall for me. Okay, so we've talked about kind of using AI to bring data into your DAG, using AI to build your DAG. There's one more aspect of this that has been of interest to me, which is taking data work that you've already done and that your data team, your analytics engineers have already validated it, you've already written your code, you might have already done your analytics, and just helping that be further spread or distributed across your organization. One of my favorite quotes ever about DBT was Tristan told me back in the very early days, it's like, DBT helps you solve hard problems once. And I think that there are some ways that AI can take the hard problems that we have solved once and make them more usable and distributed. So I'll give a very small example of this, which is recently I had a question about a data anomaly that we had internally. I'm on the dark side now. I'm not on the data team anymore, and I did a bad thing. I slacked someone on our data team. And I was like, hey, like, what was up with this data anomaly? And so Brandon, he was so kind. He was like, hey, can you actually take that exact same question and paste that into Notion AI? And I did that, and I got back the answer because, like our data team had already done like a great write-up of this. It was all just like the exact traditional data work that you would do. But now instead of having to go and answer the question of, hey, where do we do that analysis? We can take the data work that the team has already done and just make it so that people are actually finding it and using it. And so that's kind of like to talk about like back to Ian's point, like the systems that we're using, improving and like getting that for free. But then there are also some analytics engineering specific parts of this. So last November, the DX team did a really fun experiment where we took an open source text to data benchmark that Juan of data.world had put out, where basically he was showing that you could get better results for using text to natural language questions of your data if you layered on top knowledge graphs, and then if you were to try and do it based on kind of traditional SQL. And I saw that and I was like, I wonder if the dbt semantic layer would work for this. And so we had like a really fun week where we were like prototyping what would it look like for the dbt semantic layer to answer natural language questions on top of this kind of like complex enterprise data source. And so what we saw was like, one, it worked. The semantic layer outperformed kind of the traditional text to SQL. But two, the thing that was really interesting, and Lauren, I think this gets to your point, we still have to understand the data really well, because it's one of the questions that we wanted and needed to answer. The data was actually really complicated, and the system wasn't getting it until we went into our DBT project and we added a description to the relevant row that said, hey, like if this row equals like P, it means policyholder, and if it's AG, it's agent, or something like that. And by adding that knowledge of the data and getting that in there, then the system was able to understand how to apply the filters, how to apply the logic. So really, like at its most interesting and most optimistic, the role of the analytics engineer in a world where we're using AI systems is around going and getting this deep understanding of your data and then building it in, but then not having to answer that same question, 1,000 different times as we've all done again and again. So lots to talk through on Gen AI, but now I want to, before we bring it to audience questions, do a quick deep dive onto what the top challenges facing data teams are today and how we think about them. So we got to this a bit with ambiguous data ownership and poor data quality being the top two challenges. But I just want to, before we move on to audience Q&As, and please get your questions in for Ian and Lauren here. Ian and Lauren, any thoughts on how to address poor data quality or ambiguous data ownership beyond what we have, what we've discussed so far?
Lauren, you want to go first?
No, I was going to let you go first.
Okay. I mean, I think like, I don't think I'm exaggerating too much to say, there's 500 people on this call. They've all probably read about data contracts. And I think like something that can probably occur is a whole bunch of analytics engineers are like, we need data contracts. The software engineers are giving us crap data. And then like, meanwhile, a software engineer is not watching this conference. And so I think for us, certainly we have some similar problems, right? We, like everyone, have situations where a product is launched and it's not instrumented. And I think for me, it's really around setting up a system of incentives. That means you have to build not just great products, but products that are instrumented really well. And so a couple of examples of this, right? Ramp's first product roadmap included things like international reimbursements. We had to build international reimbursements to close international customers. We frankly weren't all that curious about usage of international reimbursements because it was more something that people had to check off when they were on a sales call. We didn't A/B test it. We didn't really care about what a ramp looked like without international reimbursements. We needed to build it as fast as possible and call every business that we hadn't gotten on the platform because they needed international reimbursements. We are now getting to the point where we don't have those products anymore. We have things where we need to think, is this actually better? Is this better than it used to be? Being able to compound both the 1% improvements, but also fix the 1% bugs, you need to have an instrumented product. And so for us, some things we're working on are saying, okay, if you're going to roll something out, it has to go through beta before it goes through GA. If it goes into GA, you need to talk to me in advance about how you're going to know this thing is successful. That means that stuff literally cannot make it to GA if it is not instrumented and proven to be doing better against something. So this doesn't mean that it's fully perfectly instrumented, but it does force an engineer and a product manager to think, not only how do I build a product, but how do I build a product that is instrumented enough so that I can prove my hypothesis so that I can roll this thing out. And so I think for us, it is sort of like a thing where I think front-end engineering teams can say it is hard to document instruments well. I think probably what I'd encourage analytics professionals to do is like really get in their shoes, ask, okay, why is it hard? Figure out what they're doing and why, and then try to help them make that a little bit easier. And so I think that's a big thing for us. And then the only other advice I'd give here is I think oftentimes companies have to not decide, but between, should I instrument everything? Should I build a data contract for everything, or should I do it for the 20 things that matter? And I would highly recommend doing it for the 20 things that matter most, and then adding a 21st thing if you need it. And that's sort of been the approach that we've seen. It's not perfect, but it's better than nothing. And I think it gets better every day.
I totally agree. I think the two things that you've really hit on there, Ian, is communication and prioritization. Those are the absolute most important thing here, because again, we have smaller data teams. We have to prioritize, otherwise things won't get done. And if we spread everything out into adding contracts to everything, or, trying to figure out just how to spread things across everything possible, then we're going to end up in a weird state of like everything's broken. Everything's a little bit broken and a little bit working, and it's not going to be great. So yeah, I think prioritization and then like really over communicating and making sure that we are all on the same page is huge.
Yeah, no, that makes a ton of sense. And so when we're talking about communicating, we're talking about getting systems in place to make sure that as we are deploying new changes to our code, we can trust them. Something that just came up in the chat, I'll take this question and abstractify it a little bit, but I'm curious to hear how each of you think about CI/CD in the process of data quality, and what systems do you have in place, and what are table stakes right now, and then what are kind of the higher level or more ambitious things you can do to ensure that that you have confidence in merging your changes to your code.
I think our CI/CD is probably the best of any companies in the world. We have spent a lot of time on it. And I think the reason why is like, we are the financial backbone for companies. We have a lot of stuff that needs to be right to the cent every single day. But a couple of the tools that we use are Foundational and Metaplane. One of the phrases that, I think we grabbed from Nick Schrock, who's the founder of Dagster, is shift the error left. And for me, that sort of means if you see something break in production, that is more expensive than if you break it in dev, which is more expensive if you break it in staging, which is more expensive than if you sort of figure it out when the data is loaded. So I would say that's really what we try to do, is think about, okay, for every single thing that we're trying to calculate, what is the absolute earliest stage that we could detect an error? And for some things, right, if you're talking about a wrong value in a single row of data, you can do that when you load it in. For other things, for example, what was Ramp's card transaction value, that needs to be aggregated. So that calculation happens a little bit later. But loosely, I'd say being very opinionated, not just about testing, but what is the earliest that you can perform that test and why would you want to do it? That's loosely kind of the main parts of our CI/CD. Everything else for us, I would say, is a little bit more around developer experience. How can you use clones? How can you use different Git branches to make it so that you can iterate with a team of 30 people developing against a DBT project quickly and confidently?
Yeah, I think that's absolutely right on. I mean, I think especially as a developer, I want to know when I've written bad code before my reviewer. I think that is something that people forget, right? They want to write code, they want to merge it into main like as soon as humanly possible. But really, don't you want to know that you messed something up and you overlooked an error before it gets to another human being? I do. So I think that's really important. Yeah, you want to test things early. You want to test things often. You want to make sure that that CI/CD process is kicking back to the developer anything that is broken before it gets to the next stage. Because at the next stage, that's when you have someone who's missing a little bit of context because they didn't write the code. They're sitting there going like, this looks right. And maybe I can merge it into main. Maybe it's kind of broken. But so then you have to spend more time in a discussion phase instead of just the developer going like, oops, this is broken. Let me go back and fix it, which has saved me many, many times.
Your life is always going to be better if it's if it's a DBT or a data system telling you when your code is bad, rather than something escaping into production and causing errors down the stream. So yeah, you want to shift this as close as possible to the direct work that you're doing. Okay. So this has been a really awesome conversation. I want to thank everyone that has been chiming in questions in the chat and keep going. We've got about 15 minutes left here. So with that, I want to start picking out questions from the chat. Great question from Dustin Wells, who asks, how do we get the product owner mindset and approach for analytics? Like, how can you think about building your data as a product?
Oh, I interpreted that question differently.
Wait, how do you approach it?
I was going to talk about like how you get data team members to be opinionated product owners.
Okay, great. Let's hear that.
Cool. Yeah. So, I think the best piece of feedback I've gotten about the data team at Ramp is people say, I want your team to tell my team what to do more. And when I talk about analytics engineering and sort of like what the ideal skill set looks like, just sort of one anecdote is we wanted to do something on customer service that required us being able to staff our teams for the next year. We hired an analytics engineer, and the tools that we use didn't have connectors easily accessible in Fivetran. So the first 2 weeks of this person's job were basically like getting really good at data engineering quickly and pulling APIs to get data out of these systems into our warehouse. The next week was like bread and butter analytics engineering, dimensional fact modeling. But then the last chunk of this work was like, okay, we need to make a recommendation for how many CX heads we need over the course of the next year. This requires being able to work with a finance team, with an ops team. You need to make assumptions about how many CX tickets there will be. Will CX tickets grow exponentially, linearly? Will we hopefully make our product better over time so that there are fewer CX tickets per dollar spent or company on Ramp? This is a very, very, very different skill set than that first one, which is read API docs and get data into a system. And that's largely what I think the job is, which is we hire people based on analytics engineering, but then expect them to have just-in-time learning and figure out what's necessary for impact at that specific step, and what your day and job looks like on a daily basis are super different. And so that's kind of like how we try to drill in like product ownership mindset for a data team member. We really try to never say like that specific piece is not my job.
Yeah, I think this goes back to like the very beginning of what we were talking about with there's the technical problems which we have to solve, but then there's the people and the business problems which we really have to be able to get both of those together. Lauren, curious to hear kind of how you've been seeing this with the teams that you work with.
I mean, I think there's a lot of blur between all of these different stages, right? Like you've got data analysts that are doing analytics engineering. You've got analytics engineers that are doing data engineering. There's a ton of blur. I think what's really important just as an individual contributor is to remember that like your job is, you're good at your job because you know where to look, not necessarily that you know the answer. So I think that has really helped me throughout kind of my career and like trying to figure out, what is my job? Am I doing data engineering right now? Do I do analysis? And part of that is really understanding just like, I know where to find the answer. So going to those certain places and making sure that like you can actually build out that stuff and build that knowledge and those skills.
Awesome. All right, we have time for probably 2 more questions. Let's start with this. How would you start measuring the ROI of a data ecosystem or product?
Yeah, I can take a stab at this. For us, more so than most data teams, we embed people deeply into product engineering, data, and design surface areas for a long period of time. And the reason why for us is I think we're lucky to be a little bit more mature. But we also have very few areas an analytics engineer can parachute into for 2 weeks, build a model, understand all the context, and parachute out of. And so I would not say that we evaluate the work of a data team member on their own. We evaluate the impact that they're able to drive in a specific product surface area. And I'll give you an example of this. Ramp has an accounting product. I don't know much about it. I never did work on that team. We hired someone who was the first analytics engineer on that team. And honestly, I think their first 3 weeks, they were pretty confused. But it took a while to get the business context on what the accounting team was trying to do. And eventually they looked at something and they were like, look, human beings are labeling travel or like Delta flights as travel over and over and over. Why are they doing that? Like, this is a data problem. We can build a classifier. And then you have to work with a design team to think about how would we represent the confidence that this specific transaction should be coded a certain way? How can we work with the engineering team to have that appear in the back end the way that we want? How can we work with the product manager to make sure this fits in with what we're thinking? And eventually, we were able to build an accounting coding product that was not suggested by a PM or a designer or an engineer. It was suggested by a data team member. And so for me, that's an example of something where I do think we have the luxury of putting people deeply in pods and saying, go drive impact. But we measure a little bit more based on the impact that they provide to their team. If our accounting product sucked and no one adopted it, but the dashboards on how unadopted it were extremely clean and precise, to me, I don't think that's success. And so we really try to evaluate the impact they have on the actual product and product adoption, as opposed to sort of like their little silo of the stack.
Keeping it de-siloed and having people close to their domain teams and close to the data problems they work on it's maybe the most important thing that we've talked about yet today. So with that, I want to get to what will probably end up being the last question that we have time for, from DBT community legend Jenna Jordan in the chat, asking what's next for DBT Mesh, particularly around making it easier to solve the people and process problems. Lauren, what have you been, first of all, can you give us just a quick definition of DBT Mesh, and then talk about kind of how you have seen DBT Mesh working to make it easier for teams to solve people and process problems?
Yeah, absolutely. So DBT Mesh is essentially our system to allow for cross-project references. So what can happen is you have these embedded teams that Ian was just talking about. You've got these little pieces. You've got many different siloed pieces of your data stack, because you've got marketing, you've got your people ops data, you've got your customer success data, you've got all these different things. And some of them rely on some of the same data sets. And so what happens when you have these like separate projects that are not referencing each other is you end up having kind of siloed pieces of code. And that means you can't reuse code. It means you may be calculating things in different ways, and that's not great. You're both reaching for the same raw data, but you're renaming columns in different ways. And it gets really confusing. So you don't necessarily have like a single source of truth. So with DBT Mesh, what you can do is kind of reach across the aisle and say, like, our core team has built out all of this underlying, all these underlying pieces of data set, or all these data sets. Can we just use your version? Because then we don't have to rebuild it. And that's what data mesh is allowing for. So it will streamline calculations. It'll allow for making sure there's consistency and allowing for like a lot fewer models to be built, honestly. So what's next? How does it help solve the people and process problems? I think it actually, requires more communication. Again, communication and priorities is huge to me. So I think that's one of the main things here, is that it kind of forces you to reach across to your team and say, I need to use this data set. I need to make sure that you never change the name of this column, or you don't, at least for the next 3 months. Let's throw a data contract on it. So there's a lot more of a dependency pun intended, DBT pun intended, on other teams and making sure that that data looks the way that we expect it to, because we're going to use it kind of across the board in a hub and spoke way.
Awesome. Yeah. So I think that that's exactly right. And it's the concept of taking what are the ways that we can build kind of technical infrastructure to allow for the solving of the people in the business problem. And it's never going to be just one or just the other. We have to build the right tools. We have to have the right kind of culture set internally. We have to share knowledge. It's kind of all of these. But to the extent that DBT can provide the mechanisms to allow data teams to do this work, to decentralize their data, to be close to their problems, that's definitely something that is very, very top of mind for the near future. Oh man, I'm sad this is ending. This was such a fun conversation. I want to thank everyone that joined us in the chat today, everyone that participated in the survey, and a huge, huge thank you to Lauren and Ian, our expert panelists. So really, really great session. Grateful to them for having joined. I think that you can find them both on the DBT Slack if you have anything that you want to connect on. And then before you leave, a couple quick notes. The first is within Goldcast, the very webinar platform which you are watching this on, you can do you can do the following things. Get started today with your own DBT Cloud trial in the docs section of Goldcast. Even better, you can get a one-on-one DBT Cloud demo if you click on the orange button in the top right corner of Goldcast. And finally, if you have questions, comments, feedback on today's section, please let us know in the Goldcast doc survey link. So with that, I want to say it's been a really fascinating year in analytics engineering. Really grateful to everyone that has shared thoughts, and we're looking forward to continuing to help build out the tools that allow all of you to solve the problems in your data organization, to get closer to the data. And we're looking forward to seeing you back at one of these sessions in the future. So thank you all, and have a wonderful rest of your day.
Thanks, Jason.
Thanks, Jason.
Thanks, folks.